Hello, my name is Keshwani. That's Keshwani, Keshwani. We are here because we want to improve our math skill. Today is our day number 34. I have put the problem on the blackboard already, which I usually don't do. I'm going to read it to you in the event that you have trouble reading my handwriting. Well, I shouldn't phrase it like that because I know you will have trouble reading my handwriting. Let's read it together. It says persons A, B and C work independently. Persons A, B and C work independently. This is independently to solve a given problem. So there is a problem that is given to three people, A, B and C, and they're working independently on that problem. They're not working together. We are told that the likelihood that each of these persons will succeed at solving the problem is 1/4. In other words, A only has a 25% chance of succeeding at this problem, at this task, whatever the task happens to be. B has only a third of a chance, about 33% chance, and C is just as likely to fail as he is at succeeding, or as she is at succeeding, because it's 50%. There's a 50% chance that she will succeed and 50% chance that he will fail. And of course, during the process, she goes through a gender change, but we won't talk about that. The question simply is, how likely is it that no one will succeed? That everybody will bomb, everybody will muck it up. Second question, how likely is it that only A will succeed? A, who we are told has only 25% chance. So how likely is it that the person who has only 25% chance of succeeding will succeed at the task, but the other two people who have greater odds of being successful will actually flunk? That's the question here. And last question simply is, how likely is it that A and B will succeed, but not C? The C person who has the highest probability of succeeding in the task, 50%, we are told that this particular attempt, that person C does not succeed, but the other two people do. Time now to pause the video and solve the problem yourself. Once you have the answer to all of these three questions, you can resume the video. Okay? I'm going to read one more time to you the question, just in case if you are having trouble reading it again one more time. Person A, B and C work independently to solve a given problem. The likelihood that each of these three persons will succeed at solving this, each of these persons will succeed at solving this problem independently on their own is 1/4, 1/3 and 1/2 respectively. How likely is it that no one will succeed? Okay. How likely is it that only A will succeed? How likely is that A and B will succeed but not C? I'm going to take a couple of sips to give you a chance to pause and unpause the video after you've done your solutions, and then I'll continue talking. Alright, then let's get going. Very first one. A, number 1. Let's give it Roman numerals so we can discuss, so it's easier to see. Let's look at A, number 1. How likely is it that no one will succeed? Well, here is your A, here is your B, and here is your C. How likely is it that no one will succeed? Well, we have to ask ourselves, how likely is it that A will fail? We know that A has a 1/4 chance of succeeding. If A has a 1/4 chance of succeeding, that also means that A has a 3/4 chance that he will fail. I would just stick with he, because I find it awkward to go between he and she, because I don't want to soon begin to start questioning my virility, so let's just stick with he. How likely is it that B will bomb it? We know that B has a 1/3 chance of succeeding, but if B has a 1/3 chance of succeeding, which is same as saying that B has 2/3 chance of bombing it, of flunking it. Oh, it says 1/2. Tell you what, I'm going to change that 1/2 to something else, because the problem with the 1/2 is that when I'm trying to show you, see for example here we have to put down how likely is C of failing. Well, the chances that C will fail is same as chances that C will succeed, because I put down half here, and you will not be able to see the difference between the two concepts, and it will be a little confusing. Let's put in something different, something easy to see. Let's cross out this 1/2 and put down 3/5. So if B has a 3/5, so I raise its odds a little bit from 50% to 60%, you understand? So if C has a 60% chance of succeeding, which also means that C has a 40% chance of not succeeding. And the question is, how likely is it that no one will succeed working independently? And since these are independent events, all you have to do is just multiply the probabilities. And now, all we have to do is simplify it. These 3's will cancel out, this 3 will go with this 3, and the 2's and the 4's will cancel out. See, 2 times 2 is 4, which is going to cancel out with this one. This guy goes, and that guy goes, and this guy goes. So we are left with, oh, that's it, 1/5. The answer is 1/5. 1/5. There is only 20% chance. There is only 20% chance that no one will succeed. Okay. The interpretation is of this thing is that there is only %20 chance that they will all muck it up. That's an M. As I always remind some puritanical people, so Americans get very worked up, it is an M, not an F. There is only 20% chance that they will all muck it up, that none of them will succeed, all 3 of them will fail. Let's do problem number 2. Second problem. I need to pick a different color marker. So that was it, number 1. Where can we do number 2? I'm going to erase the top part here so that I have the room to do the second questions. I don't want to go any. Maybe we can do one more on the bottom. Number 2. What does number 2 ask? How likely is it that only A will succeed? Well, same exact thing that we did before. Only A will succeed. So here's your A, here's your B, and here's your C. The chance that A will succeed is 1/4. But since we are asked for the odds that only A will succeed, which is not very likely. A has the lowest odds of getting this problem right. So how likely is it that the dimwit among the 3, with the only 25% chance of being successful, will in fact succeed, and the other 2 will fail? Not very likely at all, which you will see in a second. So A has a 1/4 chance of succeeding. How likely is it that B will fail? B has a 2/3 chance of failing. How likely is it that C will fail? C has a 2/5 chance of failing. Just like before, there's a 2/3 chance of failing. You see here, this 2/3 represents the odds that B will fail. Because B has a 1/3 chance of succeeding, therefore he is 2/3 likely to fail. So that does not change here. C has a 3/5 chance of succeeding, therefore he has a 2/5 chance of failing, which is what this is. Only thing that has changed here is that instead of 3/4, which are the odds that A would fail also, because that was the first part where no one will succeed, here we want A to succeed. The odds that A will succeed is 1/4. That's all. Again, these 2's cancel out with the 4, and we are left with a chance of 1/15. 1/15. Since we know that 1/5 is a 20% chance, you should know your fractions. 1/5 is a 20% chance, and since we also know that 1/15 is a third of 1/5, and therefore a third of 20 is approximately 7%. As you can see, not very likely at all. Not very likely at all. Only a 7% chance that the guy who is the dimwit, with only a 1/4 chance only a 25% chance, will in fact succeed, but the other two people, the smarter people, will actually fail. Not very likely. Only a 7% chance. Let's do the very last one. Very last one, let's do it on the top here. How likely is it that A and B will succeed but not C? A and B will succeed but not C. Well, C has a 3/5 chance of being successful, therefore he has a 2/5 chance of not successful. And A and B will succeed. A has a 1/4 chance of succeeding and B has a 1/3 chance of succeeding. So that's all it is. That's all we have to do here. The 2 cancels out with the 4 and 2 times 5 is 10, so it's 1 out of 30. 1 out of 30. Another way of saying 1 out of 30 chance, one other way, technical way of saying that 1 out of 30 chance that both A and B will succeed, which have a lower odds of succeeding than the guy who actually has a higher odds to start out with. Perhaps, if you want to keep it simple, perhaps this is first grader, second grader, and third grader, and they are given a math problem. And based on the previous experience the teachers have, they figured that first grader only has a 25% chance of solving this math problem. Second grader has a third of a chance, and a third grader has a 60% chance of figuring out how to solve the problem, if you want to keep it simple. So here, the last part we are saying is that, how likely is it that the third grader will actually fail at solving the problem, but not the first and the second grader? To which the answer is, another way of saying this thing is, 1 out of 30. Another technical way of saying the same thing would be not bloody likely. Not bloody likely. Highly unlikely that the third grader with the chance of the 3/5 of solving the problem will actually fail, but the other two will succeed. Not very likely at all. Not bloody likely. That was the end of it for today. I hope you found it helpful. I hope you got something out of it. If you wish to get hold of me for personal private tutoring for GRE, GMAT, SAT or TOEFL, go to any of these website addresses that you see there and send me an email, or you can simply go to keshwaniprep.com and send me an email from there. Alright? Thanks.